Any doubts up till now?
Yeah, I have it.
Yes. Please unmute if you don't have any doubt. Any doubts? If you have any doubt, you can mute yourself. First of all, I'm audible now. Yes, Shaurya. Okay. You can unmute yourself and speak. No doubts and concepts. Okay. Actually, this week I was a bit busy. Actually, I had a submission, so I haven't replied to your mails. But now only today, only after this class, I'll reply to everyone's mail. Whosoever has mailed me, I'll reply to them. And you can ask in the class also. So let's start. Don't know why this pencil is not working. Wait a second. It's connected. Don't know why it's not working. Just hold for a minute.
Madam, if you are using Apple Pencil, probably you have to connect it to Bluetooth.
Yes, it's connected actually.
And also probably charge, maybe charge.
It's charged as well as connected, 100% charged as well as connected. That is what I'm looking, why it's not working. Okay. So now we'll go to value function based methods. Last class, any doubts? I'll again ask. So what we did last class, just if like 2 minutes glance over, what is ML? That was simply the basic thing, the supervised, unsupervised learning, what is reinforcement learning? And then we came up how reinforcement learning was inspired by the behavioral system, like a dog example, we took Pavlov dog. And then what is delayed reward? What is the immediate reward? What is the policy? what is exploration versus exploitation. Then we came up to tic-tac-toe example, that how we are doing. Then TD learning, temporal difference learning, this immediate RL. Then then we came up about the introduction of MAP techniques, what is asymptotic correctness, what is regret optimality, and bit about pack optimality, which we'll discuss more in detail about like MAP techniques as well as pack optimality in this class.
Madam, just one confusion when I'm reading about asymptotic correctness. Let us assume that in the context of a multi-arm bandit, we have K arms, and we don't know the distribution of each of these arms. So what do we mean by asymptotic correctness? With reference to this example, can you say that, for example, I randomly pick any of the one arm, and I do it, I randomly pick 1 million times. How does it converge? So I could not visualize the experiment first.
Asymptotic correctness means like after this 1 million, after this, whenever I'll pick this arm, it will be only the best arm.
No, but all 1 million I'm picking randomly, right?
Here we are saying that asymptotic is basically a theoretical approach. It is not a like experimental approach. It's a theoretical bound theory, basically theory based. What they are saying, if you pick up this arm multiple times, that arm will be the best one. That arm will give you the highest reward, basically.
Same arm? Is it the same arm I picked out?
We exploited. Then we came up with the conclusion, okay, this is the best arm. Now, after this concept, after this procedure is done, after this number of times I'll like pick up that arm, like now I have done some Thompson sampling greedy or epsilon greedy approach, the MAP technique. Then I'm saying that now I came with the approach A is the best arm. Now I'm saying how many number of times after that I'll pick that arm will always give me the best reward. That arm will always give me the highest payoff than the other arms, basically. That is what the asymptotic correctness is. Now we are giving you the guarantee that this arm will be the best arm, no matter what. After doing some MAB approach. After doing MAB approach, we are not saying in the starting only we'll say that arm is asymptotically correct.
Okay, ma'am.
Now let's go to this. What is Q star of A?
The value of taking an action.
Estimated reward rate.
Yeah.
Optimal value.
Yeah.
The best optimal value of the action arm A.
Reward.
The true reward associated with the action.
Is it true or estimated? Someone said estimated as well.
It's true, ma'am. So estimated is denoted by
Is it
capital
true?
Q.
Yeah, that
Yes. Now what is this?
Estimated.
estimated reward received at time t.
What is this?
Value.
What is the difference between these both?
Value is accumulated like throughout the experiment, and we only get it after the whole experiment is done. It's the cumulative rewards.
And what about capital Q?
So it's like at one instance of time we are getting that capital Q.
Then what is R?
R is basically the reward. Like
Then
QT.
you are saying that at one instance we are getting capital Q. Then what is R difference between Q and R?
Madam, you explain once again. This exactly I'm confusing. Okay.
I'll tell you, I'll explain you. Just having the discussion, I'll explain you. Just wait a second.
Q is basically what we expected the reward will be, and R is the actual reward we received at an instant.
Okay, we received at that instant, that is R, and capital Q is the estimated reward. Then what is V?
Is it the value of a state? Is it
Then
the value of a state?
Basically, this is the estimate. I'll write a line, and I think professor also told you this line, but I want to go in deep. What do you mean by this?
Madam, there is another word also used called return. So that also this clarify. Return.
That is G. I'll explain you. Yes, you're correct. I'll clarify all of them. What do I mean by this? Estimate attached with action. I think professor told in the class that Q is estimate attached with the action and V is estimate attached with the state. Am I correct or not?
Correct, madam. Correct. So, yeah.
What do you mean by this estimate attached with action and what do you mean by estimate attached with state? Anyone?
Estimate attached with action focuses only on the estimate by taking one particular action, whereas value is the estimate by being in that state, including all the arms, by being in that state, by estimating the future rewards, by accommodating all the arms. Maybe, I don't know, this is my intuitive understanding.
Anyone else? Yes, you
Ma'am, Q is basically what we expect that an action will give, but V is the maximum reward we can achieve at a particular state by looking at all the actions.
Yes, you are correct. I'll tell you. I'll just give you the equation. I'll not denote the return because we haven't introduced the return yet. Now, what is Q? What is V? And what do you mean by this? I'm just doing this question answer so that you can have more understanding. When we discuss, we are more into thinking basically. So we shouldn't cram the things. We should more go to the understanding and thinking thing. So what are this? As you told something to me. With this, you can tell me what is Q, what is V, and what does these equations means? What does this mean? Conditional thing.
Yeah,
the first one is V and the second one is QT.
Okay, now, yes, you are correct. That first one is V and second one is QT. Now, can you tell me how, like, what does this mean?
Okay, so the first one we are only considering the state. For each state, we have a probability that we can pick up any of the arm. So if we take all the arms and consider what is the average reward we can get, that is V. And if we take only in that situation, we pick a certain arm and the reward we will get, the average reward we will get by picking that arm in that situation, that is QT.
Yes, now you are correct. All of you are correct. That if we have a particular state and a particular action is given to us, and then we have to tell actually it is GT, but we haven't introduced this expression here. So let's take it as RT only, reward only. So we are at a particular state and action is performed already. Then what is the expected reward, or you can say expected return here? Or you can say what is the best policy when that action is performed already. And then value refers to when we are at a particular state and then what is the expected reward there.
Ma'am, I have a doubt. So won't the QT isn't QT an approximation of the Q star? So like if we are assuming that given a state and an action, we are having a reward distribution. So essentially the thing is that we really don't know what the reward distribution is. So it should be an approximation, right? So
it is approximation actually.
Okay.
It is basically GT here. This is expected reward only. I'm just introducing this RT so that I haven't introduced this term. What is GT here? So it is.
Okay.
Yes,
Got
yes.
it.
So
Ma'am,
basically,
I
yes,
have
yes.
one doubt, ma'am. QT, I think it is associated to a particular action, right? Or a
Yes.
particular arm.
What? Okay, let's understand more like into deep. Now I have a state. I have taken a particular action. Then I can say, then what is the reward? Then what will be the action after this thing? I can say after this thing. This is basically QT. If I'll say, now what is the after this thing? After this particular state, in this state, then what will be the particular action? What should the action be taken so that to get the expected reward? I can, wait a second. This is after this thing. This is QT here. I am at a particular state, action is taken now. What is the best like expected reward, or what is the best policy I can say, so that I can get the maximum of expected reward here. If I talk about VT, that is, if I'm at a particular state, then what should be the action and what should be the states and all the policy here. That is basically VT.
Madam, it looks like both are related, one in equation. If you can write that.
This is the equation. What does it mean? I am in a particular state. What is the expected reward? V, value.
No, but yeah, what I'm thinking is that V also can be written in terms of QT.
Okay, let's replace it with by GT. Sorry.
Ma'am, is B equal to the average of all the QTs that is available at state is?
Can you repeat your question? Is?
Okay, so suppose we are at a particular state is and we have a number of actions or k number of actions available to us. So V will be equals to the, the QT of all those arms by k. I mean, average of all those rewards, right?
Yeah, I also feel that, madam. So at any particular state, if you have, let us say, 10 arms, so the average QT of those 10 arms becomes a V of that particular state.
Yeah.
You are saying that if you're having the 10 arms, then Q will become the V basically. You are saying this?
No, ma'am, not basically. We will become the average of the QTs of those 10 arms.
V will become the average of the QT of the 10 arms. I am at the state S. Now we don't know what at V, we don't know what is this particular action performed. This is basically, we can't say that this is the best action performed here.
Yeah, okay.
You got it? Like this is, we don't know that this is the best action performed here. Or I can say more simply, wait a second. Let us relate V by Q, that is.
Ma'am, can you please clarify a little bit? I mean, what is V? I'm not getting.
Okay. What I'm saying is, this is state. I am in this particular state. Now, what I'm saying, if I'm in a particular state, what is the expected reward? So what action should I take? Like if I'm at state S, what action should I take to get the best policy or to get optimal expected reward? This is
so, ma'am. So like all the different arms are like random variables, and each of them have their different like QTs associated with it, right? And like, if I'm not wrong, is that what it is?
Okay, actually this V, if I say, let us not talk about map thing. That is where you are getting confused. Let us not talk about map thing. This is multi-arm banded. Multi-arm banded means that, or I'll get to this concept afterwards. Multi-arm banded means we are only having these arms. Arms in the, what are arms? I can say they are actions. We are not having states there. Can I say that?
Yep.
Yeah. No state.
Yeah, the state is there, madam, only one state.
I can't say that we are having states in map. No state is there. Only arms are there. We have to pull an arm which is giving the best reward.
No, but the current state, when you pull the arm, okay.
Then, actually, this is related to full RL technique. I am in a particular state. I take an action. Don't now relate it with map. Or I'll, okay, let's do one thing. I'll come up to this concept again later. It will come basically when we'll go to MDP and all those techniques. It will come later. If you are relating with map, this is just an action we are performing, and then we are getting the reward, and then we are performing the next action according to the reward, which we like according to whatever we get. Am I correct there? If I'm
Yes.
wrong.
Yeah.
Okay.
So basically we'll be picking up the action with the, max of Q.
Yes, or any other technique. This is basically greedy technique. Yes, max of Q or any exploitation technique.
So ma'am, like given a
If I-
state, okay.
Hmm.
So
Yes.
given a state, we're trying to like estimate the reward, right? At some instance of time.
Hmm.
So like, what is the random variable here? Like, just to get the idea.
Okay. Let's, if you have talked it, let's come to this full RL. I'll just give you a gist, then we'll go to full RL in detail afterwards. Suppose, let me give you an example. I'm in the state. Suppose there is an IoT device. And this is the server, suppose. IoT device is having, as we all know that IoT device are resource constraint. So battery issue is there. So main objective is I want to transmit the data to the server, and with some transmission power, I can say. Now, the main objective is there. What should be the power here, transmission power here, so that my battery should be not that much of exhausted. And as when we are transmitting, then bandwidth can obviously be changed here. So according to you, what is the state? What is the action? And what is the reward? And what is the randomness? Just I'm introducing a small example. I'll go in detail. So what do you think?
I think the state should be
The current battery.
battery charge. Yeah.
Okay, battery.
SOC.
Action.
The transmission power. The amount we exhausted.
Reward.
The
Is the
decrease.
Yes.
The remaining battery or the decrease.
Decrease, I can say. That is the cost. Basically, what is the randomness?
The data flow from the server.
What is the randomness? Bandwidth, which is changing, I can say. Which is affecting this transmission.
So more bandwidth uses more battery. That's like, I don't know.
Bandwidth can, like, this is just a toy example. I'm saying there is a random bandwidth and I have to use that transmission power will affect, like I have to send with more transmission power or less transmission power. Don't think that much. A toy example, just a toy example. So this is how I have mapped the state, action, reward, and randomness. As you were saying me, what is state, what is action, reward, randomness. And now I have to make a policy, basically, which will say that with how much transmission power I should transmit if I'm in this particular battery. This is just a toy example. So that my lesser battery should be, like one more factor can be there. We should transmit it at more speed also. Like time also is suppose the constraint, as well as energy. I mean, the battery is also the constraint. So at what transmission power I should transmit so that I shouldn't take that much of time. And at the same time, if I increase the time, the energy will decrease, or I can say the battery will decrease. So at what transmission power I should transmit so that my battery shouldn't be consumed that much And at the same time also shouldn't be consumed that much. And the randomness is the bandwidth. So what action should be performed? This is just how RL can have the, like, how can we have this full RL questions here? Got it? Yes, I'll go and take it up.
Value is like given the battery percentage at one instance of time, like what kind of like rewards are like, what is the distribution of the reward?
What action should I take if I'm in a particular, okay, value is basically that if I'm in that particular battery, then what should be the action, or how the action should be performed, what action should be performed after I'm in the particular state. And talking about the QT, that is, I have performed the first action, then afterwards how it should be performed. I'm talking about full RL view. Yes, we'll come to MAB again. And then I'll discuss this whole thing again. This will come in next classes. Don't worry about that much. I think I'm talking way ahead. I should stop here and I should come to MAB thing. And when we'll come to this class, I'll again come to this thing. Same example and same everything, same diagram will come. Some idea you got it?
Yes, ma'am.
Yeah, can you, but just one last thing, can you tell what G is? What is GT?
GT is basically the expected reward. That also I was not introducing because someone said in the class that can you tell me what is GT? Let us take it as a reward only. Not don't think that much because I'll introduce this term GT as well.
Okay.
Is the class going confusing or you are getting?
No, ma'am, it's going good.
Okay. So, Shaurya, I think you are saying something. Can you unmute yourself? About V.
That was my, it got clear. So the equation will not hold, right?
Yes.
The equation I sent in chat, the summation, will that hold or not?
A star.
Madam, but implicitly in my mind, there is a relation between V of S and Q of S.
Yes.
Okay.
Yes,
somehow if we can write it down, I think our doubts will be clear.
Okay. Let us say, actually, I'm not introducing that because that thing will come into full RL. I shouldn't have introduced in this class. I should have gone forward. Just because the professor said this thing, estimate attach with action, estimate attach with state. So I thought, okay, let's go forward and then explain you.
Okay, no problem. Go ahead, madam. Go ahead as per your plan.
Wait a second. Max of A, if I take the max of A and then Q of S. Okay. Though this, okay, I'll explain in the future classes this. Think this will be the equation if I'll say that max of A is taken and then Q. Okay, let's go forward and then I'll come back when we'll introduce this full RL thing. This is just a map thing. Map is where we are only doing the actions thing and we are not talking about the states. You got the full RL concept as well, like what is state, what is action, what is randomness, what can be the randomness?
Yes, ma'am.
Yes, Gopal. VS is the expected reward of being in the state and then moving to the next state by taking the problem.
Yeah, I got it clear. No, it is not average. It is the reward of the arm which gives the maximum Q.
It is actually the average reward only. I'm not introducing everything here. That is the return only. I'll come back. Don't worry.
Okay, madam.
Smita, you are having some doubts? Okay, let's go forward. So what is K-arm bandit? I can say that. We'll choose the arm. After each choice, you receive a numerical reward. That depends on basically your action. So the objective here is basically maximize the total reward. This we discussed in the last class as well, that we are choosing an arm, we are taking an action, and then we are trying to maximize the total reward here. Expected reward here. Let's not go to states. Let's stay here only. If I have chosen the particular action, then what is the expected reward? That is our Q star of A. Done. Now
Yes.
coming to the greedy approach. What is greedy? What is epsilon greedy? Though we discussed somewhat in the last class. Yes.
Greedy is just picking the best action at every instant, and epsilon greedy is being explorative with a probability epsilon.
Yes, you are right. One more thing. Okay.
So sorry, just to clarify, like isn't Q star the true value?
Yes, it's basically, you are correct. Thank you for pointing out. That is the true value, that is the expected value. Am I correct? Let's proceed. So I can say that greedy is basically the argmax A, QT of A. Basically, whichever will be the maximum, that will pick it up. And then why we need exploration? That also we discussed here. Is the exploration greedy or there is no exploration?
I have no exploration in greedy, only exploration.
So that is why we came up with the epsilon greedy approach. Like as you told that with 1 minus epsilon, we'll go with the argmax A QT of A, and with epsilon probability, we'll uniformly basically choose from that. So this is basically epsilon greedy and greedy. I also told you one of the tutorial, that's Stanford one. So let's go there. Okay.
Ma'am, I just have one query. Where can I get the previous week's session? Is it available on YouTube?
Yes, previous week's session is available. You can check on YouTube, Prablin Kukreja, with the name of that. I actually uploaded today only. I was busy this week. From this week, I'll take care about that thing. I'll now upload after this lecture only.
Okay, ma'am, can you please paste the link in the chat?
Okay, I'll write the name of the channel in the chat.
Okay, ma'am, thanks.
Yes, Vatsal, I have uploaded the previous Sunday's video. And Smita will get to full RL like in the next lectures. Don't worry about that full RL technique. This is now you have to get about the map thing, basically. So this is the concept which is talked in this basically the thing. Now what they are saying is, suppose I have here, there is written basically, suppose that this distribution basically it says that the agent tries action 1. The agent tries action 1 and 2 1000 times and action 3 times regarding the cumulative and got the cumulative reward 600, 401. So what it is saying that we have 3 arms. Arm 1, arm 2 and arm 3. So arm 1 is tried, like picked up 600 times. Arm 2 is picked up 400 times and arm 3 is basically picked up 3 times. And now we got this result. This result says that 0.4 times the action 2 is better, and 0.6 time action 1 is better. And this is the action 3 which is given to us. So which arm is basically better? Can you tell me? Did you got the concept? What I'm saying is we have 3 arms. Now we pick up one of the, like we picked up 600 times we picked up arm 1, 400 times we picked up arm 2, and 3 times we picked up arm 3. And then, okay. Now here I get 0.6 probability, 0.4 probability, and 0.4 probability, which means that arm 6, basically 60% of time it will give me the reward 1, 40% of time it will give me the reward 1, and 40% of time it will give me the reward 1. So which is the best arm according to you?
Arm 1.
Arm 3 is not explored that much, so maybe it has potential.
Yes, you are right, and Shara, you are also right. As we wrote in the chat, that arm 3 is not explored much. Though I got the result that 60% of time arm 1 is good. And what about arm 2?
Ma'am, should we not only compare between arm 2 and arm 3? Because arm 1 is already giving us like good amount of result. So like, oh yeah, okay.
What are the other other students' views about this? Like, should we explore arm 2 and arm 3?
I think arm 2 should not be explored because it has already been explored this much, but it is still giving less result than arm 1.
So now what we should Yes.
Ma'am, arm 1 is better than arm 2, so we don't think we need to explore more on arm 2, I'm saying. Arm
Yes.
3 needed to be seriously explored.
Yes, you all are correct. So I think so. Now you got the concept that obviously exploration is essential. Yes, Vatsal, you are also right. And Shara, more weightage should be given to arm 3 for the exploration. So that is why that is called as dithering concept here. Dithering concept says that exploration also should be done with the exploitation. And epsilon greedy is one of the dithering approach only that we are studying here. Basically, that 1 minus epsilon times, like we have to explore, and epsilon times we have to exploit. So this was the graphical view which I told you, so that you can get the better understanding about that. You have the link of this now. I think last lecture we discussed about this. Okay, now coming to this Bernoulli greedy, what does this algorithm say is that, like suppose for t is equal to 1 to 2, what they're saying, we are like for all the arms, we'll calculate this theta. Let us say that alpha is equal to 1 and beta is equal to 1. What does this mean? Then theta is equal to 1 over 1 plus 1, which means theta is equal to 0.5. So what I'm saying is, let us say the distribution of all the arms, theta means the distribution of all the arms, like arm 1, arm 2, 3, be, first of all, we'll assume 0.5. What do you mean by 0.5 first thing? Let me clear that
It's
everyone
like
knows.
0 or 1, like 50% probability.
So what is this distribution called?
Bernoulli distribution.
Yes. What does Bernoulli distribution?
Like tossing coins.
Yes,
Only
you're right.
2 possible outcomes.
Hmm?
Ma'am, only 2 possible outcomes.
Yes, you both are correct. Like tossing coins, experiment with 2 possible outcomes, like probability of x is equal to 1 with the probability p, and x is equal to 0 with 1 minus p. Simply that. So now arm 1 is equal to 0.5, which means that 50% of time arm will give the reward and 50% it will not give the reward. So let us take theta of all the arms equal initially, because we don't know which is the best arm. So what will be the xt? Yes.
0.5.
So is it 0.5 or something else?
It will be some so
Why it will
an
give,
arm will be selected at random.
why it will not give 0.5 and arm?
Oh, okay.
Yes.
Because we are returning argmax k, not
What
theta k.
What is the difference between max and argmax?
Argmax means the index at which the maximum value is placed.
Yes.
So basically, it will return the arm who has the maximum value.
Yes, you are correct. Argmax here refers to the index. So if I say max of theta, then what it will return basically?
If the values are equal
0.5.
at the instance of time, then it should actually return any random arm.
Okay, no, I'm getting you that it will return any random arm because it's argmax. I'm saying if it is return max of theta instead of argmax, then what it will return?
Then 0.5 in this case.
Okay, so now we'll say that it will return any random arm. Then we'll apply the XT and then we'll observe what is the reward here. And okay, let me take an example and then solve this rather than telling you like this only. Okay, so let us say that all of the arms, let me take the page here. So let us say I have arm 1, arm 2, arm 3. Now theta is equal to 0.5, 0.5, 0.5, which means 50% of time all they'll give that. Now I'm selecting any of that arm because all are equal. So let us select arm 1. Now apply XT and observe RT. So suppose now I'll apply XT and suppose this arm give me the reward 1. Suppose that. Now I have to update the distribution. What is the update of the distribution? Says alpha xt, like let us alpha beta given alpha plus r. I'm not writing clearly just for the simplification, minus r, which means that alpha and beta were 1 and 1 earlier. Now it's like 1. 2 and 1. Am I correct? Any doubt till now?
Ma'am,
can
can you please repeat the updation part?
Okay. Let's see. Now what we are saying it, this theta is done, this xt you got it. Suppose this reward we apply xt means we got an arm, suppose 1, and we got the reward 1 basically. Suppose this reward is 1. Simply I have put the values. Alpha was 1, reward is 1. 1 plus 1, 2. 1 plus 1 minus 1, that is 1 only. So just simply I have put the values. Alpha plus alpha is 1 plus 1, 2. 1 plus 1 minus 1, that is 1 only. So alpha beta 2, 1. Got it?
Got it.
Okay. Now again I'll go back. I'll update the theta. Theta is equal to alpha over alpha plus beta. Now what is this is arm 1, arm 2, arm 3. Now I can say 2 over 2 plus 1, that is 2 over 3, I think. Okay, let's say 2 over 3, and arm 2 is basically 1 by 2, and this is also 1 by 2. So it's like 0.6 something. So we'll select the argmax, then we'll select this theta basically. This is how this algorithm here is working. This is greedy algorithm. And obviously if the probability of this is greater, then now it will choose always the arm 1 here. It will not choose arm 2 or arm 3 there. Because now again I'll do, and suppose for 2-3 times I get the arm 1 is the better one. I'll choose the arm 1 only. I'll not explore the arm 2 and arm 3. Do you got this algorithm? I'm very fast at speaking. I should be slow. I think so.
Got it.
Got it?
Yes, ma'am.
Anyone else? Doubts? We'll go to Thompson sampling also, but afterwards. If you got it, please give thumbs up on the chat or write that you got it so that I can proceed further.
Ma'am, I just wanted to ask one question.
Yes.
Say we get a reward 0 for
Hmm.
this one, and we keep getting a reward 0 for a number of times. So alpha would remain same and beta would increase. So won't the probability of arm1 go down?
Yes, yes. That is what is the algorithm. Okay, let's try. Now you are saying, let us say we get the reward 0. Reward is equal to 0. So now let us update this. Alpha, beta. Alpha is equal to 1. Reward is 0. Beta is equal to 1 plus 0 minus. Oh, sorry. 1 plus 1 minus 0. So we got alpha beta as 1 and 2. Now let us update it. Others alpha beta is 1, 1. This is arm 2. This is arm 3. And this is arm 1. So now let us update its theta value. What is 1 by 3?
0.33.
Now, what about other 0.5? 0.5. So which arm we'll choose? Whether we'll choose A, as you were saying now, A will get lower down every time. We'll choose A or we'll choose B or C?
We'll choose B or C. So, ma'am, basically, so the time taken will be more, but eventually this will also give the correct results.
No, why this will, okay, can someone answer her question? Why this will not give the good results? What is the limitation or what is the flaw? Yes, come on, let's make this class an interactive one rather than.
Ma'am, if it keeps on giving the reward, then we are not exploring. We are
Yes.
only exploring when it's not giving a good reward.
Yes, you are correct. I think my screen is not sharing. I should share. Wait a second. You got your answer, or I should explain it again?
Actually, I was asking like in the earlier example, the probability has gone to 2 by 3. So what I was asking was that if after this step, it gives an arm 0, it gives a reward 0, so the arm 1 probability will be lowered down, right? So,
Okay.
so this will keep happening. And I was asking if in infinite steps, it will eventually give the correct arm only.
Yes, ma'am. To some extent, I was also thinking the same.
Okay, okay. Now suppose the reward is 0. Okay. Now, wait a second. Now I'm saying that theta A is there. Now theta A will not choose. We'll choose basically the B, arm B here. There can be the case where greedy also perform well. There can be the case. We are not saying always the greedy approach performs don't perform well. But there are the cases where greedy will not perform well. How? Let us see that. So now I'll say arm B. Now suppose the arm B gives the reward 1. So the probability of arm B will increase.
Yes.
Now again I'll choose the arm B. Suppose, okay, let us say that we have 50 runs. No. Like let us say in the first 20 runs, arm B is performing very well. After that, arm B don't perform well. But now the probability is so high of this arm B that we are not able to cope up with arm C and arm A basically, because their probability is very low in the starting. What I mean is, in the starting, if some arm is performing very well, then its probability will be very high. Can I say that?
Yes, ma'am.
And the probability of other arms will be very low as compared to this probability, and they be can I say that also?
Yes, ma'am.
So if this arm A is not performing well in 2-3 rounds or after some rounds, then also its probability is high because it has gone so high as compared to the other one.
Yes, ma'am. Ma'am, now I got it.
One more person was not getting it. You got it?
Yes, ma'am, got it, clear now.
Because that probability has gone so high after some rounds that still, if we are updating the beta also, then also that probability is very high.
So it's not possible to cope up with the increased
Maybe
probability.
after many rounds, we can say yes. At that time, like you are also right, after many rounds, we can say we can cope up with that, but it will obviously take a lot of time and we can't give that guarantee as well.
Got it. Got it.
Now coming back here. So greedy, an example you have seen, and now epsilon greedy also, that it will behave greedily most of the time, but once in a while with the I can say with the small probability epsilon, it will select from all other actions with the equal probability or uniformly, I can say. Am I correct?
Yes,
Okay.
ma'am.
So now let's go to incremental implementation. We'll come, or I think let's go to the softmax here. So what is the limitation in epsilon greedy? I think last class also one of you answered only.
Ma'am, after a certain period of time, we have to decrease the exploration and only exploit the optimal arm. That's not possible.
Any other limitation? Yes, you are absolutely correct. This was discussed in the last class only. When I was also thinking that about any other exploration, then like any other limitation, then it clicked into my mind. And I think professor has told.
Yes, ma'am. One more limitation will be there, like if two arms are very close in rewards, and one arm is just slightly greater than the other, so it will have a greater probability, and that nearly good arm would have the same probability as the bad arms.
Yes, ma'am. Yeah.
But madam, a solution has been suggested by sir that decrease the exploration by epsilon by n.
Please, whosoever is not asking the question can mute your mic. Yes, you were asking some question. Carry on. Any doubts? I think someone was asking. Okay, let's proceed. No doubts. Can I proceed?
Madam, just one thing. The sir has told that in epsilon greedy, we have to reduce the exploration as we proceed to increase the number of steps. Like for example, he said the probability is no more 1 minus epsilon. It is 1 minus epsilon and plus epsilon by n. Epsilon by n. So
Yes,
that is also a good strategy, right? To reduce exploration as we increase the number of steps.
Yes, yes, you are correct. That will come to that point also, that we can basically reduce the number of steps when we are closer, like we can cool the epsilon or we can decrease the epsilon basically. But we shouldn't decrease it as fast. So we should take care, like how should we increase, at what rate should we decrease. I think that point is basically somewhat there, that how at what factor, like he might have, like he has told, I think epsilon is inversely like directly proportional to 1 by t, but actually that is not used in the practical setting as well. So how to decrease that, with what proportion you should decrease that. So that there are also some like there are some questions like how the epsilon should be decreased. Am I correct?
Yes, ma'am.
Okay. Now coming to and one other thing, like which he told, that one of the student told now only, that when the two arms are basically very close to each other, then giving the probability one to the like giving the choosing the arm which is like 0.001 higher than the other arm and keeping the other arm in the exploration stage, that is also not the correct approach. So if the difference between the two arms is very small basically. So that is why these are the reasons that we came to the softmax or Thompson sampling or any UCB or other approach. Okay. Can anyone explain this?
This is the like reward Q estimated value at time t divided by the sum of all the values.
Now, why we came up with this, the second equation?
That because in the first one, the probability can become negative.
Yes.
So to incorporate those, we are exponential.
Now, what is the role of this now, beta?
This is the temperature, like
What does this temperature refers to?
like if beta is like very high, then it's essentially an uniform, like we are just no, like uniformly we are
Randomly
giving, yeah, randomly choosing. So as we cool down the beta, so then it will be we'll be driving it more in a softmax way.
Yes, you are correct. That beta is like a temperature. How what does this like beta tell us, like how much we should explore and how much we should exploit? In one sense, it tells us that. Okay. I was thinking some mails came to me for the WhatsApp group as well. So I was thinking, let's make a Slack group in which I can post some questions. You can post the questions, like you can have the discussions. And rather than mailing me, we can be in the Slack group as well. But I haven't created, or in the next class, we can create that. I can create and I can share that. Yes, Shaurya, we are talking about the stationary problems right now. Okay. You were saying that epsilon, if we decrease the epsilon with time, yes, it will not work. So I was thinking to solve the questions, but now time, we don't have that much of time. Okay. I was thinking now, okay, let's proceed. Total expected reward, suppose I have arm 1. Or let's post these questions in the Slack only. I'll post these numeric questions in the Slack only, so that we'll understand the concepts here, do the coding questions or the numerical questions there, and get the better understanding, so that we can utilize our time efficiently there. Now coming to incremental implementation. Why we are doing this incremental implementation? What is the disadvantage earlier?
We have to store all the rewards in the previous time steps.
So can I say that with storing, we'll have memory
Yes,
constraints, computation constraints? Yes, you're correct. Now, as we know that what is QN, basically, I haven't written that term here. Can someone explain me in detail about this?
This is the average of all the rewards we have got till now after we chose the I.
What is, okay, what is this?
This is an indicator function which will be one only if I is selected at a time instant.
So if I will be selected, then I'll get the like 1 into the reward. And what is this? The number of,
These are, yes, number of instances where I was selected.
yes, you are correct.
Kill
Or,
time.
yes. Or I can say simply R1 plus R2 if A, okay. And now let us take it as N only. Discrete only, rather than taking T here, continuous there. Or I can say Qn plus 1. Wait, like I'll explain you. I have to go through the proofs also, but time is like 7 o'clock. Okay. So Qn is basically the average. That is what I have written, Qn plus 1. I'm not following. I'm following the not following the class procedure here of the incremental. So, in like, are you getting first of all what is Qn plus 1? Qn is equal to the average over the total count. This one. Then that is what I have written here. And then we came up with just I have written n minus 1 here and Rn I have written here. So instead of writing 1 by n summation of Ri, what I have done 1 by n Rn last term, and here I put n minus 1. Should I proceed?
Yes, ma'am.
Sure. I'm not listening any yes here. Only one yes is there. Just I have now divided and multiplied by n minus 1. Nothing else. What is this?
Qn.
Qn. Yes, you're correct. Don't worry, I'll go above and then explain again. Rn, let's open this bracket. So Qn outside plus 1 by n Rn minus Qn. Same thing became. This is the incremental approach. Okay. Now let's go again. What I'm saying, it is summation of this. Then what I'm saying, let us sum it over n minus 1 and keep it Rn the last term here. That is what I have kept. I've divided and multiplied by n minus 1. Now, this is basically the same term here. Here I'm taking summation of n. Here I'm taking, if I'm taking n minus 1, then I have Qn. Here I was having Qn plus 1. And then Rn plus n minus 1, I've opened the bracket. N Qn divided by n, it is basically Qn only. So I kept it outside. N Qn plus 1 by n, Rn minus Qn. Any doubts?
No, ma'am.
Got it? So what is this term? What is this term? What is this term? Can someone explain me? Just I have, I think professor has not done this, just some deviation and came to the same thing again. So can you
This
tell
is
me?
the fraction of the error with which we want to update our like previous Q value.
What is this?
So this is the estimated value at nth step.
I can say old estimate.
Yeah, old
This is the
estimate.
new estimate at time step, as you told, as you said that it is the estimated time n. This is the estimated time n plus 1. So new old. What is this?
Number
Uh,
of steps
Or
or
maybe learning rate.
Number of
You
times we
can.
have chosen that arc.
yes, ma'am. Number of times we have chosen an arc.
Step size. So what is this?
The reward
What is
received
this?
by picking at nth time.
And this same old
That is
estimate.
the old.
So this is how basically I can say that
Ma'am, Rn is the current reward, right? At the init stage, the step that I have got.
Rn is the reward at time nth. Wait a second.
Yeah.
What is the reward? I think there is something wrong here. Basically, Rn should be the target here. This is basically the old estimate plus the step size, and this is the error there. Error of the estimate. But this is here the old estimate. It should be the target there. And okay, let's proceed
No,
further.
Rn plus 1, no. It will be Rn plus 1.
But here I'm taking.
Haven't received like reward at ns plus 1 of time.
You're correct. You're correct. Rn plus 1 minus Qn.
Okay, so Rn plus 1 is the reward that I have got now at n plus 1. Yeah, got it.
So shouldn't the step size also be n plus 1? 1 upon n plus 1.
Yes, ma'am. The equation is saying that, yeah.
Qn plus 1 by n plus 1.
Because otherwise at the first time we are picking it, then n will be 0. So
First time n is yes, you're correct. But here we get it n. There. I think something is wrong with this derivation. I should see it. We came up with this average, then 1 Rn plus summation Rn n minus 1 n minus 1. Then we came up with n minus 1 Qn Rn plus, according to this, it should be Rqn plus 1 by n. Okay. Okay,
I think according to this terminology, Rn was okay because we were calculating the Qn plus 1 we will take at n plus 1 at stage. So we updated it using the previous stages value, I think.
Yes, she is correct. That is why I was getting confused, like how the derivation. Now,
Yes, ma'am. Sorry for that. Yeah.
Rn is at time n. We are calculating an n plus 1. When the professor was telling, he was telling n and n minus 1 because he was taking at time t and then he was referring to time t minus 1 and so. So now what we are saying is that what is the reward which we are getting at nth time step. If any doubt is there, you can ask. I'm also getting confused with this. Actually, I switched from T to N and then should I proceed?
Yes, ma'am.
yes.
So basically, this says that more weights should be given to recent rewards than the old ones. How it is saying that? Let us see. Let us say this as alpha only. And Qn plus 1 is equal to Qn plus alpha Rn minus Qn alpha Rn plus, let us take Qn as common, and 1 minus alpha. Now again, what is Qn? I can say that Qn is alpha Rn minus 1 plus 1 minus alpha Qn minus 1. Got this?
Yes.
I took the same thing, and
Yes,
then
ma'am.
just simply I'm substituting the same value here by taking Qn, Rn, like Qn I'm taking, so I'm taking Rn minus 1 and Qn minus 1. So again, I can say here alpha Rn minus 1. I can split this again. Like, wait a second, I'll come back. Alpha Rn plus 1 minus alpha. Let's open it. Alpha Rn minus 1 plus 1 minus alpha square Qn minus 1. So basically, what I mean here, that when we are going ahead, like what I mean here, that more weightage is given to the more recent one. Like if we alpha is basically from 0 to 1 basically. So 1 minus alpha square, and more recent one will get the more weightage here, and the previous one will get the lesser weightage. That is what I'm trying to explain to this derivation. Got this? Or I should go again?
Ma'am, got.
One thing, in the last equation, it would be Qn minus 2, right? Because twice we have like decreased.
Wait a second. Alpha Rn plus 1 minus alpha. Okay. Now Qn, I have done it. Alpha Rn minus 1 plus 1 minus alpha Qn minus 1. Then we came to alpha Rn. Yes, Qn minus 2 here. Alpha Rn minus 1. Yes, it should be like the main motive of telling is that as we go ahead, like the more weightage is given to the recent rewards than the old rewards. Or a simple equation can be written like, okay, let's leave that. Otherwise, more confusion will be there. Should I go ahead?
Yes, ma'am.
So can someone tell me about the UCB algorithm?
Ma'am, in UCB algorithm, we give a upper bound to the pin card recreate
Okay.
So in
during
UCB,
exploration. Yeah.
we consider both the current estimate we have and the uncertainty in the estimate. So that like we took the example of 1, 2, 3 arms. So 3 was only tested thrice. So that will have higher uncertainty. So its estimate can be more than the first arm.
Yes. Yes, you are correct. That if its uncertainty is greater, then we can't say anything. Then that arm can be greater than that arm. Then what should we do?
Consider
Yes.
the uncertainty while like choosing probability of picking arm.
Okay, let's see that pictorially and understand it. First of all, let me write this same thing. Play each arm at least once. It's at least once, not only once. Many of them get confused that it's always only once. Play arm J. That maximizes. You all got the proof, like how that UCB is working. The proof, basically the upper bound proof. I'm sorry, how.
Ma'am,
Yes.
I have a doubt in the proof. The one particular expression I can't get it.
I think you mailed me as well the third condition. Na?
Yeah.
Yes, we'll go through it in detail. So what does this refer to, anyone? What is QJ? Again, I'm asking.
Ma'am,
The
the
estimate
third
of
condition.
the estimated of reward of arm J.
You're not audible. Can you be somewhat loud?
The estimated reward of arm J.
Yes. What is this expression basically? What is this?
Number of times I have sampled arms. I have chosen arms basically.
Then this?
The total number of times I have picked any arms.
Yes, you are correct. Let's go forward. Any doubts up till now? I'm assuming that you know this.
Yes, ma'am.
So what we are doing here, we are not only just going with the estimated expectation, we are also going with the confidence there. Like what is the confidence, with what confidence I can say the expectation is right. Okay, let's forget this UCB. Anyone has done CI, confidence interval? Anyone has plotted CIs? Okay, leave that. So basically, suppose
Confidence interval that is, like we have alpha which is 0.5 or 0.05, that thing
yes,
in distribution.
can you be loud?
Yeah, like that we use in hypothesis testing, right? Confidence interval.
Yes. Actually, whenever we do some work, we'll not rely on the single sample there. We rely on the confidence interval. With this confidence, with 95% of confidence, I'm saying the expectation is this. That is basically when we come to the confidence interval. Like I am having, I'll not run an experiment for one time. This 30 is basically a central limit theorem. Okay, let's not get into it. Like minimum of 30 times I'll run the experiment and then I'll get some confidence interval which will say that, like I'll give this 95% or 90% of confidence, that how if I'm running the experiment 30 times, with what confidence I can say that the expectation lies within this curve. That is basically the confidence interval, and this is also like what we are talking about, that with this much of confidence I'm saying that the reward is this, with this much of confidence I'm saying that this reward is this. Q1, Q2, Q3 and Q4. So which is the best arm?
Four.
Sure.
One can be sampled more number of times if it is able to reach till the fourth arm estimate.
So now why she has said that like first arm should be sampled more number of times, anyone?
Ma'am, that because after sampling the confidence bound will shrink and it may happen the value will go up. for Q1.
Then I can see that Q3 is also having a lot, huge, this confidence here, like
Its upper limit
huge
is
bar.
less than the
But
lower
max
limit of
of Q3 is
Q4.
less than the mean of Q4. But
Mm-hmm.
if the max of Q1 is greater than the mean of Q4, so it has the potential chance to get over Q4.
Yes, yes, yes. So if we'll sample it many times, then what will happen? It will be broaden up or it will be shorten up, this interval.
Shorten.
Shorten.
So that is why I said the same thing, that when we are experimentally doing the simulations, I'm not running it one time. I'll run it more and more times. It is not related only to RL, just specifically. We used to draw this CI here, confidence interval, for any plot we are doing it, because you can't say that this is expectation, and this is greater. So you have to plot and you have to tell that they are not overlapping when we go to the real setting. So when they are not overlapping, this means that this is basically the best one. Got it? Should I proceed further?
Yes,
ma'am.
Though we have lesser time. Okay, let's go to the proof there. For all k belong greater than 1, if UCB 1 is run on k arms, have arbitrary reward distribution with support in 0, 1. Then what is expected? So in the assignment, you are getting MCQ based or theoretical or coding based questions?
I'm coding this तो कुछ नहीं.
Okay. How to do the code? Okay. So we'll discuss the codes and all in the Slack group only.
Ma'am, can you please keep some Python demo? Ma'am, Python demo demonstrating the algorithms in Python.
Okay. So next, though I demonstrated the last time when I was teaching RL. Okay. So next time we'll do the map techniques in the Google Colab notebook only. The map, epsilon greedy, Thompson sampling also I'll introduce it and I'll do it, and the softmax UCB, everything there.
Okay, ma'am.
Okay. No? Because the class is going more theory based here.
Yes, ma'am.
So this is the upper bound which they are saying. Okay. Now what is the what is this delta I? What is I? Okay. Don't come to delta I. What is I? What is A star?
The A star is the true base star, and I is action or a arm that we have chosen.
The arm.
What is I didn't got you. What are you saying? What is A star?
It is the true base star.
It is the true arm, I can say, optimal arm, I can say.
Yes.
I is the arm which we have chosen.
Yes.
So what is this delta I?
Q star of A star minus Q star of I.
What do you mean by that?
Ma'am, estimate of the true estimate of the best optimal arm minus the true estimate of the suboptimal arm I.
Okay. What can I give the term to it?
Distance of the i's value from optimal arm.
Can you repeat it again? What you say?
Difference of the reward of arm I from the true optimal arm.
Yes, you are correct. In a single word, what can I say?
Error.
Distance.
Yes, error or loss. Can I say that?
Yes, ma'am.
So loss we'll incur if we'll play or if we'll pick arm I instead of optimal arm. Am I correct if I'll say this term?
Yes, ma'am.
Let's go forward. So what is this?
Will time step in how many times I have picked the arm I.
So basically, played arm I in first end trials, I can say. How many times I've picked arm I in the coming to the regret. Explain you everything, just hold. Now, what was this delta I?
I'm
Loss
Error.
or regret, I can say, of playing that, picking the arm I instead of A star, basically. TI of N is
Yes.
how many times I have picked that arm I in N trials, number of times, and the sum of it. Basically, it is the expected number of times I picked the arm I instead of A. That can I say that as regret?
Yes, ma'am.
Okay. Now,
Regret is the sum of like for all arms, right?
Sum of
Yeah, we have the summation I at the left.
What is the regret of optimal arm?
0.
Zero.
Why?
That because Q
Because
star
delta I is 0.
Why delta is 0? Q star of A star, and that is also the optimal arm, so difference is basically 0. Okay, what is xi of n?
Reward obtained by choosing the arm I at the stage N.
Yes, simply I'm saying that this is the reward obtained by choosing. This is just the terminologies as I thought that you have done it. So let's revise that. Actually, it shouldn't be expected the reward. Okay, let's say close to because it's true here. Okay, now we are saying that expected TIN basically that is the regret here should be bounded there. That is what we are going to prove this in this theorem. Let us go forward. What is concentration inequality? Please stop me if I am going very fast or if you have any doubt.
Ma'am, no idea about concentration inequality.
Okay. So concentration inequality is basically like how slowly I have the number of samples, how slowly or how quickly my estimation is approaching the true expectation. I'll write it. What I'm saying is I have some number of samples. Now I'm estimating the expectation. And on the other hand, I have true expectation as well, which is like a true value as well. So how quickly or how slowly this expectation is reaching to the true one, the estimated one. That is basically the concentration one. got the intuition behind it?
Yes, ma'am.
So coming to the Chernoff Hofting, before jumping into that. Can someone help me in telling what is Chernoff Hofting bound?
Probability of Sn greater than equal to mu plus epsilon is less than equal to e raised to the power minus 2 epsilon square n.
So basically, what is Sn here?
Sn is the current mean that we are calculating.
Estimated mean, I can say.
Yes,
Yes.
yes.
What is mu here?
True mean.
Okay, what is epsilon here?
It's the error.
Error.
An arbitrary constant greater than equal to 0.
What you said? Can I say it as error?
Yes, ma'am.
Yes, ma'am.
So what does this equation is telling me? What does it? Okay, you told me that this is the estimated mean. You are telling me this is the true mean. What you are telling me this is the error. Now what does this equation tells me?
Ma'am,
So
if
as
we
error will increase, the probability will decrease of that error.
ma'am, if we sample from a random variable from its distribution for a number of times, then the probability of the estimated mean from the true mean to be far away from to be epsilon apart is less than e to the power minus 2 epsilon square n.
Can I say that how this term as only this term, can I say that how far Sn is from the mu? How far the estimated value is from the mu? Is it telling me that?
Yes, ma'am.
And this is giving me the upper bound of this, that it should be less than the estimated mean and the true mean difference should be less than this.
Yes, ma'am.
This is basically the Chernoff Hofting bound. That how much should be the difference between the true mean as well as the estimated mean, how much up, like the probability of the true mean as well as estimated mean with this error is upper bounded by this probability. We'll again go to Chernoff Hofting bound when we'll discuss about the path learning in detail. Should I proceed forward?
Yes, ma'am.
So here only. Here only we use this term. Let us say this is equal to Cn. Nj means how many times I've played the term, which is I'm denoting now by S. I is the integrator function, which says that value is equal to In is equal to I. Value is equal to 1 if In is equal to I. Otherwise, value is equal to 0. Now I'll write one equation and then we'll discuss. Now, can someone tell me what is this? Let us go very slowly. If I am also doing
Number of times I is selected.
number of times I is selected. Okay, this is this. Then what is this? This is basically number of times I is selected. What is this?
This is the number of times I was selected in k+1 to n trials.
Yes, you are correct that. How many number of times? First, why 1 is here?
And
Because in the starting, K trials were made, and in each of the K trials, one arm was selected. So initially, K arms would be selected at least once.
Okay, so that is why here k plus 1 is there. First time k, like, can I say?
Yes, ma'am.
Yes, ma'am.
Should I proceed?
Yes, ma'am.
Now let's go ahead. Can you explain me this?
Ma'am, this means that first we selected the arm I L times, and then we counted it from the instant of k plus 1 to n, such that previously we'll check that we have selected the arm at least L times, then only we'll count the trial in which arm I was selected.
Yes, you are correct. Now what she is saying and what does it mean? That first L time, suppose we are selecting it. And if it is selected, if this TIM minus 1 is greater than L, can you tell me what is TIM minus 1 greater than L? What does it mean?
Yes, ma'am. So till m minus 1 at time, if the number of times I have taken the action I is greater than L or equal to L, then only I will count that, because I have already added L. So admin, we are, uh, I mean, our assumption is we have taken the action I for L times. That's why we are only adding after that.
You are correct. L, we have chosen L times. We have already, as you told, that we have already done it, added L, so no need to count it again. So count the other arms if it is equal to I. Am I correct?
Yes, ma'am.
Let us go forward. When arm I will be selected?
When its estimated reward will be greater than others.
When Q plus that bound term that we have is greater than, is the max.
Others, or I can say greater than the optimal one.
Yes, ma'am. Here I have a question. So it is here we are overcounting actually. I mean, uh, because we are only specifying the optimal arm A star, but it needs to be greater than eventually all the other arms to be very specific.
If it is greater than all the arms, can I say it is greater than the optimal arm?
Yes, ma'am.
So that is what it should be greater than. You are right. Arm I will be selected when it is greater than all the arms. Or if I'm saying that arm I is greater, arm I is greater than the optimal arm, then arm I is selected. Both are like, can I go to this term?
Ma'am, I have a doubt. I mean, in this particular case, it may happen that I have another arm, which is A prime, which in that particular instant is giving an estimated reward greater than the A star also. It is also possible. Then in that case, for the selection of arm A, the arm A must exceed the estimated reward of the A prime also, along with the A star.
Okay, so you are saying that suppose I have two arms which are greater than A star.
Yeah.
And suppose this ith arm, more than ith arm, someone's reward is there.
Yeah.
Then it is greater than ith arm as well. So we should consider all arms instead of this.
Yes, ma'am. Yes, ma'am. But ma'am, here it's also that is also being justified by the upper bound or the greater than equal to sign. Yeah,
Yes.
that's why it is correct, I think. I was just trying to clarify it. I'm not sure if I'm thinking right.
This question arises to my mind now only, like I'm still having that doubt only, which you told that if the arm is greater than.
Yeah. So, ma'am, in the original video at a timestamp of 13 minutes and 27 seconds, I think a fellow student asked the same question. This one. Okay, so and then professor said, yeah, that it is a overcount. That's why we have the upper bound. I mean the greater than equal to. That's why it is being justified.
Okay.
Yeah. So can you please, ma'am, yeah, check on this whether I'm thinking right or wrong. I'm not. I am also not 100% confident.
Okay, I'll go through this doubt again. And I'm having the doubt, as you said. I'll think I'll also go through this and I'll inform you in the next class.
Okay, ma'am. Okay, ma'am. And one more thing, ma'am. Apart from the live sessions, how can I ask you doubts in weekdays?
That is what I'm thinking. We'll make a Slack group in which you can discuss with the other students as well.
Yeah.
And we can also I can also answer you. Everyone can discuss so that it will be helpful.
Okay, ma'am. Thank you. Thanks, ma'am.
Madam, just one request, like apart from the standard textbook and Bob Sutton's book, any other material which are easy to read, intuitive way to give a real meaning behind these equations? Okay, so if you find any sources, because I am also trying to search the net, YouTubes and all that, if you have something, suggest a book or a reference or
Okay, I'll see that. For the certain topics, like MAB, I suggested you the Stanford thing, and PAC learning, I can suggest you the ML books like Schwartz and Tom Michel PAC learning.
Ma'am, what was the first resource that you did?
This one, TS tutorial. For the map thing, you can go through this. This is a good tutorial, Stanford tutorial, basically. Like you can write their Thompson sampling and Stanford.
Okay, ma'am.
And then you'll get this. And mostly in the chapter 2 and 3, you'll get a good information about greedy, epsilon greedy, as well as Thompson sampling.
Okay.
Then coming to PAC learning, I can tell you that or PAC learning or ML, if theoretical, if you want to go, Schwartz, something like that is the book name. Or one more book is there. I think it's with me only.
See, one thing I find, madam, once we get the essence of the fundamentals, we can go fast. But sometimes I am feeling getting stuck in the terminology and those things only. If you can explain intuitive way, for example, whole I know multi-armed bandit. Actually, it is not covered at the end in most of the books, but some is covered right at the beginning. And that. That is only if you understand that, I think clearly, then we can proceed to the rest. I don't know.
So you are having the doubts in multi-arm banded, like greedy, epsilon greedy. Did you got it?
Yeah. I understood at a high level. I can talk. Okay,
Okay. Let's next session. Let's take it coding only, and then let's solve some problems. Maybe by doing the problems, by solving that problems, we can understand it more clearly rather than going through these proofs and all.
Okay, madam. Right, that is good.
Okay, ma'am. I have one more request. So, will it be possible for you in the end part of the course to give us a demo of DeepRL, through any projects or something like that? I'm really looking forward to get into DeepRL.
Okay, DeepRL. Actually, I'm not currently working in DeepRL techniques.
Okay, ma'am.
Okay, but yes, I can give you the project. We can work with the projects. Yes, it's fine.
Yes, ma'am. You can just how things work. You can demo through a classroom.
Yes. Yes, Smita, also I can do the Python coding only. Like it will be better Python coding. Yes, I'll work on the Google Colab at the Python coding only. Don't worry about that. Okay, I don't think so. Today this proof will be over. Let's proceed in the next class. Okay, let's just go. So where were we? Ti of n. You got this understanding? Q plus C is greater than QA star. Yes. Any other arm can also be greater than QI. Then the upper bound can help us. I can give you the more understanding in the next lecture about this thing.
Okay.
Let's. Okay, na?
Okay, ma'am.
Okay. Now let's go ahead. Now what we have done, we were here, like we were counting it. So it is basically this bracket is like we'll get one, then like we are basically counting it. This is the count here, I can say. Now what we are saying that if it is true, basically what we are saying that L plus summation of if there is Im is equal to I, which means that how many times that I'll pull that arm, that is basically we are counting, and how many times we'll pull that arm, we check that Q plus C is greater than Q A star plus C. That is what is referred here. So Q plus C Q plus C is greater than basically Q, if it is basically Q plus C of I is greater than Q plus C of A star, then we'll pull this arm, otherwise we will not pull this arm. That is what this bracket means. Should I proceed?
Yes, ma'am.
I think it's getting somewhat confusing. So let's proceed. So the same thing, if I'm saying that this is greater than that one, can I say that min is greater than max? Its min is greater than this max? Nothing. Just if the values, this one is greater, obviously the max of this one would be greater than this min. Am I correct?
Yes, ma'am. Yes,
Yes,
ma'am.
Yes.
So now going forward, can someone explain this, what I'm writing? Wait a second, let me write. Can someone explain me?
Ma'am, you're basically summing over all the instances when this arm I is having this term greater than the optimal arm. So this will basically include that instant as well. Then this minimum would be less than equal to maximum. So that will be counted.
Yes, you are correct. At some point, suppose M, or I can say P1 minimum occurs, at some point maximum occurs, summing over all possible indexes of A star and summing over all possible indexes of I can say that this is basically I'm loosening the bound. This is I'm considering all the things rather than basically minimum and maximum, and loosening this bound by loosening this bound. Got it? Rather than doing the min max, I'm summing it all. Obviously, if max and min will be included in this sum, am I correct?
Yes, ma'am.
Now coming to those conditions. What is this? I'll go again to the proof. Don't worry if something is going above the head. Don't worry about that. What is this?
Ma'am, this means we are underestimating the estimate of A star.
Okay, how?
Ma'am, this estimate is basically even lower than the optimal value minus that confidence interval, because basically this estimate is below the confidence interval of A star.
Yes. What I'm saying here is, as she said, this is Q of A star. What is this? The estimated one. And this is the true one. So Q of A star plus the confidence one, it is less than the Q star A star. Basically, when we are doing this estimation, we are underestimating the true one. Now, what do we mean that when, now other thing is, when, what are the conditions when this I will be the optimal arm? When this I, the reward of I will be greater than the reward of A star in these conditions. So these three conditions are discussed here. One is the underestimating. When we are underestimating the expected Q to be the from the true one. The second condition, can I say overestimating? Can someone explain me?
Yeah, here we are grossly overestimating the reward of estimate of the reward of the suboptimal I.
Yes, basically here we are overestimating it. Like actual was this, but we are estimating it as this. This is basically the overestimating one.
Yes.
So now, can someone tell me the third place where this can happen? Where we can choose I?
If the difference between the estimate of the suboptimal and the optimal are very small.
That is what if the difference between them is very small. So let's stop the lecture here because I want to go in detail with this difference and all of those, as there were many doubts. So let's not proceed and let's go in the next lecture and tell about this. Though I was thinking that pack learning and all are left. Any doubts up till now?
Ma'am, actually,
Ma'am,
yeah.
Ma'am, when we took the three summations, why did we choose those particular like upper limits?
When we took the three submissions, yes, then what you're saying?
Ma'am, the values of like this, like we took m equals to 1 to infinity and s is something. So why did we choose those values only?
This one you're saying.
Yes, ma'am.
Can someone tell me? Yes, I'm getting it. Only he is having a doubt or you all got it? If you all got it, can someone answer?
Ma'am, I have doubt in this line and even in the previous line also, in the min max.
Let's go again. Okay, let's go.
And from the min max, you can start.
It's fine because someone is having doubt from here. Let's just get it overview. This was just that I took the arm like this is basic. Can someone tell me what is this? Let's go fast and explain.
So this is first time we have taken initially when we have taken all k arms once, and then after the time to the point n we are at right now, how many times we got arm I?
Okay, yes, this is basically first of all we took all the arms and then how many times we got the I. Okay, done. Then what is this? Now,
Okay, so
yes.
now we change it from 1 to L because like in time m-1, which like we have got the arm I at least L times. So we have added L. And then after that time m, we are taking how many times we got L.
Okay, done. What is this?
This is the condition on which we are choosing RMI.
So when we'll choose the term I, when that is greater than the optimal one, I'll also see that as the doubt was asked. Okay, let's till now, let's assume that it is greater than the optimal arm, then we have chosen the term I. Then we came up with this. This min and max, you got it? If it is greater than this, so obviously the min will be greater than max. Yes.
Ma'am, can you please write that particular expression of the mean and max? That because in that particular expression there was an additional parameter S and SI for the base term and the suboptimal arm, optimal and the suboptimal arm respectively.
I think okay. That is why we are getting confused. You are right. Here, suppose yes, you are right. You're right. Okay, let's not go to the So this is basically this till this point. You got it?
Yes, ma'am.
You're right. Actually, I shouldn't have written M and because there the summation problem is getting. Now what I have done that here it is basically we are taking L after L only. So that is why we are mentioning here L is less than SI is less than M. And here we are taking all of them. That is why here 0 to S greater than M. And we are saying that A star basically it should be less than I. Then coming to this, now someone can explain me.
Ma'am, in that particular mean max, ma'am, can you please explain the expression in English? I am not getting the expression itself. I think I am doing something wrong.
Okay. What is this? What I am saying is what I'm saying is this is greater than this. Suppose, can I say 7 is greater than 1?
Yes, ma'am.
That is what they're mentioning. If it is greater than this, then the max of this will be greater than the min of this.
Okay.
Okay, na? This is just simply to get it more loose bound. They have mentioned it that if it is greater than this, if I is greater than A star, then the min of the max of it will obviously be greater than the min of that.
Okay, ma'am, got it.
Okay, na? Then we have summed over all the m's, or like we have take. Okay, now can someone tell me what is this? Yes, come on.
Ma'am, first from the very beginning, I have taken the suboptimal arm A, and after L, I have taken the suboptimal arm I. I am just summing them up whenever the suboptimal arm is greater than the optimal arm.
That is what we are doing. We are saying that min is greater than max. So we can simply say that over all the summing over all the possible indexes, rather than saying min or max, it will be greater than that one. The I will be greater than the A star one. If max is greater than the min, then summing over all indexes, L is L to M minus 1, 1 to M minus 1 is for the A star, and over all of them, then I can say we are basically loosening the bound, doing nothing.
Okay.
Yes, ma'am, clear.
Got it, ma'am. Clear.
Now we'll discuss again about these three conditions in the next class. think we should be fast enough.
And
Or
then, just to clarify one more thing, we have the second bracket, so those are basically indicating the events where that particular thing happens, and then the whole expression will get a count of 1. I mean, the curly braces, that's actually what it is denoting, right?
this this curly braces is saying that if it is true, then we'll get the count of 1. If it is not true, then we'll get the count of 0.
Okay,
Yep.
got it. Got it.
Any doubts?
No, ma'am.
Okay, I'll mail you back, whosoever has mailed me. And you are currently having any WhatsApp group or nothing like?
No, ma'am, but
Only like Gmail group we have.
that is of no use. It's very hard.
Yeah,
to
NPTEL
operate.
official. That is.
Okay, then okay, I'll next class only I can share it with you. I was thinking that I can share with the. Okay, let's see. Then Slack group I'll share with you, and whosoever has mailed me, I'll mail you back surely.
Okay, ma'am. And how can I in that case do I need to mail you if the Slack group is created in a week or so?
Okay, you can mail me. Yes, you guys can mail me, and I'll let you know the Slack group also. And you can see the recording in this. I think I have mentioned that channel name, and I'll upload the recording at night today only.
Okay, ma'am. Thank you. Thanks a lot, ma'am.
Thank you. Is the lecture okay, or it was confusing today?
No, ma'am. My doubts were
No,
cleared.
it's okay.
I think
Yeah, the
in
video
between-
is more clear now. The most of the videos.
Yes, ma'am. This kind of interaction is very much needed.
Okay. This time, like I can also learn some things from you, and you can also learn from me. So let's have this interaction. Like you should attend all the classes because this interaction will help everyone.
Yes, ma'am. Definitely. Yeah.
Okay.
And on
Thank you.
tomorrow's class, you will only take or the others, Abhinav?
Other one will
Okay.
take.
Okay.
You are attending both the classes, or
Yeah,
so?
like last week I attended both.
Okay, okay. There in that class, the same things were discussed, or there was some.
Yeah, it was like a repetition of the same thing. That's why I'm asking.
Okay, 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 okay. Okay, we'll discuss, and we'll make a schedule so that the same thing shouldn't be discussed. Actually, the audience is different. He said me that I asked from him. He said few of the students were same. So okay. Next class, I'll go for the code thing for the map techniques there.
Okay, ma'am. And one more question, ma'am. What is the scope of research in this particular RL domain?
RL basically the future of computer science is RL. I'll say like ML after this now we are all converging to RL, and obviously RL is a new field. So many few people are comfortable with RL techniques. So there is a bright future I can say in RL.
Okay, ma'am. And in India, which are the institutes or which professors can I mail, who have an internship under them if I want to work in this domain? Can you name few?
You can basically go to the websites of IIT and check the professor specialization.
Okay, ma'am. Okay.
But you are doing you are pursuing masters now, or?
No, ma'am. I just have graduated. I am working as a web developer, and I'm also fascinated in this particular domain.
Okay, okay. So you are thinking for the higher studies?
Yes, ma'am. In future, I'm looking for us.
Okay, okay, okay. Okay, if you have any doubt, you can mail me. We can discuss on the mail.
Okay, ma'am. Ma'am, can you please share your mail address once?
Yes. I'll write here only.
Okay. Okay, ma'am. Got it.
Okay.
Okay, got it. Thank you, ma'am. Thanks a lot.